loud?
Now it's recorded, yeah.
Okay, good. Perfect. Okay. So, okay, we're going to start the next session. I'm going to demonstrate how to make a simple movie in CellBlender. I'm going to start up Blender. And I'm going to open a previous model that we had made the other day. I'm going to say open, and I'll open our organelle demo. And here's our model. And we had already run it on Tuesday. And I'll just remind you what this looked like. Okay. And remember, in our plot output, we ran for 10 milliseconds of simulated time at a 1 microsecond time step. So our movie consists of 10,000 frames. Okay. And so movies can be as simple or as complex as you would like. I'm going to start with just something really simple where we just have a single point of view, and we're not going to make the camera move around and give us different views as it goes, but there is a way to do all that stuff, but it gets to be overwhelming. So let's just start with something simple at first. This window here is called the 3D view window. Its main purpose, its real purpose, is for letting you manipulate your world as you build your world and plan your world. And it's not really totally intended to be your final place to visualize the model for a for a professional movie, but we can kind of hijack it for that purpose, and that's a quick way to go. But really, the more extensive way to go with Blender, and people can spend a whole lifetime learning how to do it, is you can use Blender to do photorealistic rendering with Hollywood quality, final rendering quality. But to do that is much more in-depth and complicated. And like I said, you can spend a lifetime learning how to do that. But fortunately, we don't have to go to such great lengths. And there's a much simpler way to do it. And that is, like I said, to hijack the 3D view window and make it do a pretty good job of rendering our scene. So first thing you need to decide on when you make a movie is how big is the final image going to be in your movie? And you can use this interface not to just make a movie, but you can also use it to generate a single snapshot, like a still image of a high quality rendering of your scene. So what I'm going to show you here applies to not just making movies, but also to making still shots like you might want to put as a figure in a paper or in a PowerPoint presentation or some such. So the interface for controlling the size of the images and the quality of the animation is found under this properties panel called the Render Properties panel. It's the one that we talked about earlier today that has a tab with an icon shaped like a little camera. And important first thing to decide is what is going to be the screen resolution or final resolution of the images in the movie. The high definition movie standard or video standard is 1920 pixels in X by 1080 pixels in Y. That's kind of the default that you get here. So let's use that, and then you can you can scale that up or down to lower or higher percentages of that aspect ratio with this control down here. Let's go to 100% of that. But what if I wanted to go to make a 4K video? That would be twice this size. You could say 200% here. So that's a nice quick shortcut. The bar to be able to get those resolutions, the top end here doesn't end at 100%. You can go above 100%. But let's set this to be 100%. Okay. And if we're going to be making a movie, we need to decide on the frame rate for the movie. I like using 30 frames per second, but the default you saw was 24 frames a second. Well, I'm going to set it to 30 frames a second. And there's a whole bunch of other controls here that we can just ignore. And we're going to leave the anti-aliasing settings as they are and not worry about any of these other settings here. And by default, this is set up to make a PNG image, which is a single still image. Let's start with that before we make a movie. Let's learn to walk or crawl before we run. So let's leave this at as a PNG, and the compression, PNG compresses well, and it's a lossless compression. We can leave this default setting to be what it is. And the color depth, usually an 8-bit per pixel color depth is what we want. So let's just keep it that way. Okay. So now we could, if we were to hit the render button now, this render button will render an image from the point of view of a virtual camera illuminated by a virtual lamp. Somebody's saying that they're delirious after so much brain activity. It's been a long day, and this is kind of an intense topic, but I think I've got enough energy to keep showing you if you're willing to stick with me and keep going a little bit longer. Okay, so here's, and it's being recorded, so you can all come back and view this again and again when your minds are more open or less cluttered with everything we've done today so far. Okay, so if I were to hit this button, it would render an image from the point of view of a virtual camera illuminated by a virtual light or one or more virtual lights. That's what gets to be really complicated to set up. And like I said, you could spend a lifetime or many days and weeks, learning how to master all that. And if you're so motivated, I think you should. And there's plenty of tutorials on the Blender website on exactly how to do this. Really, really great tutorials on how to begin with this. But I'm showing you the really quick and dirty way for how to do this, because I sometimes get impatient and I want to be able to do a reasonably good job, but without having to monkey around with everything required to do it this way with the render button. So to start with, there's another way to do this, and you can go up to this render menu at the very top of the Blender window, and we can say Blender, we can say render, and we can say OpenGL render image. So if I hover over this, it says use OpenGL to render the active viewport. So what this is going to do is it's just going to render an image in the size over here that we had asked for, with a point of view approximately like what you see here. So since this says 1920 by 1080, but our 3D view window isn't really showing that right now, it'll resize things when it renders this image to be approximately like this, but with the aspect ratio that we asked for. So let's do that. OpenGL render image. And here's what we get. So you can see it decided to crop it like this. So it cut the top and bottom off a little bit, but you can see it did a pretty good job of rendering exactly what we saw on the screen. Not too bad. And when we, and after we have our image here, I can go down to this image menu at the very bottom of the screen and say image, save as image, and then navigate and make it be a PNG file, right? But I won't do that right now. But if I wanted to, I could. Okay. And when I have this, I can use the scroll wheel to zoom in and out. We know that the resolution of the image is 1920 by 1080, 100% of that, because we asked for it over here. So when I zoom in and out here, when I zoom in too much, I can see the individual pixels of my image. This is useful if I want to really get an idea of what good quality, how good was the quality of what I rendered. I can zoom in and get that. Okay. And then to get out of this, I can go to Window and toggle Window full screen. But I want to get rid of this. This is the render window. To get rid of this, I can hit the Escape key. I think there's another way to get rid of it, but I'm just going to hit the Escape key now to get back to our default screen. Okay. But you saw, you just saw that it had a gray background and it, didn't look too exciting. So there's some more things we can do. So to get to these other settings, to make to make the final image a little bit more exciting, I can use the numerics keypad to bring up this side panel over here. And I can navigate down through here and look for the display settings, which normally would be collapsed. I'm going to open the display settings. And I'm going to turn on, yes?
If you don't have a numerical key, how do you bring out this?
I'm sorry. The other way, you can hit the N key on the keyboard. Just point into the 3D view window and hit N on the keyboard.
N. Okay,
N. Yeah.
Okay.
Or you can see this little plus over here and you can click on the plus and it pops up. And then make it go away, you have to stretch it all the way back until it disappears. Okay.
Okay,
so,
thank you.
Yeah, sure. The N key. Scroll through it, find the display subpanel. And we're going to turn on world background. So if I turn on world background, and also I'm going to turn off the grid floor, that gets rid of the bottom. And also this says X and Y. Let's turn off the X and Y. So I guess this turns on and off the grid floor. And then these three buttons turn on and off, showing the X, Y, and Z origin coordinate system. So I'm going to turn those off. And then now I have a 3D view which is completely unencumbered or uncluttered, I guess, by these other stray lines. Because I'm not in my movie, I probably don't want to see all that stuff. Another option is to turn on only render, and when I hover over this, it says display only objects which will be rendered. Let's not turn that on. That's a more advanced thing to think about. But what it refers to is, if I look in my outliner, I've got these objects, and this controls the visibility of these objects, the cell, organelle 1, organelle 2. These eyeballs turn those on and off. And what this renderability option refers to over here is this last column, which has a little camera. This controls whether an object will be rendered in an image that you make. So even though you can see an object here in the 3D view window, you might not want to render it in your final image. And so you can think of this view here as kind of like what's happening behind the scenes. So I have these things as a reference. Like as the director of my movie, I can keep track of what these things are. But when I tell my cameraman what to shoot, I can tell him, you know, don't shoot the cell. So even though we're all looking at the cell, I can tell the cameraman, don't take a picture of the cell. And so if I do that, and if over here I say only render, you can see now that thing disappears, even though it says visible here, right? And that controls what's displayed here. But if I turn that off and I don't turn on renderability, I still see it here. But when I go here and I say OpenGL render image, I still see it. I still see it here because this OpenGL render image is kind of a shortcut to rendering. Doesn't do the rendering the same way as this rendering button does. Okay, so generally, you know, we don't want to mess with that, so we just leave those alone. Okay, so world background. So when I turn on world background, you see it turns gray, a lighter shade of gray. But what if I want my background to be a different color than gray? I turn on world background and then I go to this fourth property tab over. It looks like a little world. It's hard to tell, but those are supposed to be like, it's supposed to be like the Earth with the continents on it. It's kind of too small to really see. Okay, turn that on. And now this is going to be the background color of the world. And right now it's set to this gray, like it's exactly the same shade of gray we have here, right? I like to have some control over my background color. Well, let's say I wanted the color of my background to be white. Well, I can just crank this up and turn it into white. And now I have a white background. Maybe that's not the color I want, but there's my white background. And if I say OpenGL render image, now I have my image with the white background. Okay. If I zoom out a little bit and render again, now you can see, now it's not clipping my object. Now it fits nicely in my screen layout. Okay, might pop in just one more little moment. And then it's a little bit up. So let's, I'm gonna shift click and pull that down a little bit. Now OpenGL render image, now it's closer to the middle. Okay, let's say this is the point of view I wanted, but I don't like this background color, so I can go in here. You can play around with these things. I like, one of the colors I like is like a deep blue, come on, like a really deep blue like that. And now that'll be a solid deep blue background. And now my final image looks like this. That's looking prettier. And then what if I want there to be a gradient in color between the bottom and top? I can say blend. And the zenith color it will be like, I guess this is like black or almost black. Let's like make it be really black. And if I do this, it doesn't look like there's much of a gradient from bottom to top, but that's because the sky is going from the horizon to the zenith is actually straight over our head. But if I want the horizon and zenith to be the bottom of the image and the top of the image, I can say use paper sky instead. Meaning that the sheet of paper is the extent of the sky, I think. That's what that means. And now you can see I get this nice gradient from blue to black. And when I render, I now get an image that looks like that. That's starting to look nicer. Okay, so let's say this point of view and this, and this, this screen layout is what I want for my movie. And this fixed point of view is what I'm going to have. I'm not going to move the camera around or anything. I'm just going to have this fixed point of view. I can have that. I could also save this as a PNG still shot to put in my PowerPoint presentation or publish in a paper or whatever. It's a PNG, it would be a PNG image. You could then pull that into Adobe Illustrator or open source software like Inkscape, and then you could put titles on it. You could put titles on it in here too, but sometimes it's easier to do that in some other program. You can look on the web in Blender tutorials to learn how to put fonts and text and things like that in your scene here. There's a way to do it. Okay, so now at this point, we'd be ready to go back to the render properties panel and set this up for making a movie. So the way you would do this is you go down here and instead of a PNG file format, we can click on that and we can make a, since I'm on a Mac, movies. I don't see some of the Mac possibilities, but I'll make an FFmpeg video. I think that's usually the most portable movie you can make. One of the most portable types of movies you can make. So I'm going to say FFmpeg video. And then for the encoding, I'm going to use, let's see, QuickTime. And I think on a Mac, you can use QuickTime. On other things, you might say AVI. So let me make an AVI instead. And the codec H.264 is pretty good. Output quality, I'll say high quality. And encoding speed, I'll say, yeah, I guess it's set for medium speed. We'll just do that. That controls how hard the computer works to produce the high quality that we asked for. These other settings we can ignore. We don't have any audio in this file, so the audio codec is none. Okay. And then here is where we tell it where we want the output file to go. Here I'm going to say put the output file in our current directory. It's going to go in this directory, and the file name that it makes, I think it will automatically make the file name for me. But if I say movie like this, I think that'll be the beginning of the name of the movie. I'm pretty sure. We'll find out here in a second if I have to tweak that, if I made a typo or if I've forgotten how to do this the right way. Okay, so now at this point, oh, and to make this go quicker, I could render all 10,000 frames, but to make this go quicker, I'll say let's just do the first 300 frames. So at 30 frames a second, that would be 10 seconds of video. So just to make our demo today go a little quicker, we don't want to wait for the whole thing. I'll say 300 frames. We're ready to go. Start from 0, end at 300. And don't get confused. Don't click on this way to do it over here, because that's the high quality way that requires a camera and a lamp to light the scene. Go over here and say OpenGL render animation. And when I do that, it's actually doing it right now. That's how fast it's doing it, which is pretty fast, because all it has to do is use OpenGL to move the particles around, just as we were doing, on the fly, in real time. But of course, it's rendering it at a much higher resolution, and saving the files and encoding the images to make a movie. So it's got a bit more work to do. and it's almost done. Now, you should know, or an interesting factoid is in Hollywood. Hollywood has kind of a rule of thumb for when they make computer graphics animations that the maximum amount of time they're willing to wait to render one frame of the movie is about 45 minutes. These frames are rendering at several per second. But in Hollywood, when they make their final cut for what they're going to show you in the theater, they're spending about 45 minutes to render each frame. And so over the years, as computers have gotten faster and faster, what you can do in those 45 minutes has gotten to be greater and greater and greater. But they still stick to that 45-minute cutoff. And of course, they're rendering on huge compute farms in parallel. So each frame is rendered in parallel on thousands of processors at a time. Okay, but anyway, so there we are. It's finished. So now I can exit from here. I can go back over to my let's see, demo. I can go back over here, and here's our movie. So it did prepend the name movie to the beginning, just like I wanted it to. And it's called movie 0000 through 0300. And so it tells us what frames of the movie it made, and it's an AVI file. And then on the Mac, I can open that movie file by just saying open, or I could pull up QuickTime. You know, I could go over here and let's see, pull up QuickTime, and then tell QuickTime to open that file. But on the Mac, I can just say open that file. And oops, can't open. Okay, so it didn't like, Apple QuickTime did not like that movie, but there's another movie player that will like the AVI file. It's called VLC. And so I'll go into VLC and I'll say open file. Let's see, it's giving me a hard time here. Documents, Bartol. Let's see, cell modeling workshop demo. Here's our AVI file. Now I can say open it, and VLC does know how to open an AVI file. And VLC is an open source movie player. And so there's our movie playing at full speed. And there it was. That was our 10 seconds of animation. And from here, from the simple beginning, you can get fancier and fancier and make it so that the camera moves and navigates around your scene, so you can see things from different angles, like in the movies that I showed you on Tuesday, and like what Terry showed on Monday. But I think what I just showed is enough of the demo for making a simple movie. And to do all those other things, you could learn from the Blender tutorials online for how to make better quality movies using the tutorials at the blender.org website. Okay, so do people have any questions about that?
I have one question, Tom. I tried to make a movie from another simulation that I did.
Okay.
And it's rendering now. It has 1,000 frames, so it's taking a while.
Okay.
But somehow I managed not to get the view that you. I didn't like it. Everything looked. It rendered like it was zoomed in on a surface, but then when I went to do the render animation, it changed to a different view.
Oh, that might have been because you hit this render button instead of this render button.
Oh, you're not sharing anymore, right?
Oh, I'm sorry.
Oh, no, yeah. Maybe you are. No, you're not. You're not.
I'm not. Okay, let me, yeah. So this, it can be, you know, this user interface is so incredibly overwhelming. you know, that it's easy to click on the wrong buttons. Okay, so the type of rendering I just did defaults to render from the current point of view of the 3D view window. It will always render what you see from this point of view. And to do that, you have to say render OpenGL render image. Not this. Don't click on this render.
That's what I did, yeah.
Yeah, this render, it says render active scene.
Right.
And the scene includes the camera and the lights and the action, right? Lights, camera, action. And when you do things this way, you really are like a director of a CG, computer graphics animation studio. In fact, if you're the only person making the video, you're the director, you're the production person, you're the camera operator, you're the lighting operator, you're the grip, you're everything, right? You're the dolly operator. So the dolly operator, so the cameraman is the guy sitting looking through the lens of the camera on a set in Hollywood. But that camera might be sitting on top of a dolly that has to roll and move. Well, the cameraman doesn't move the dolly operator moves the dolly, right? And so all these controls are available through the Blender interface, but we don't, and when you hit render here or animation over here, all those parts of your scene, what they call here scene, all the different moving parts of your scene turn on and get activated to create your movie, right? But that's a lot of moving parts. So that's why I like, for quick and dirty things, using this OpenGL render image, because this just does, okay, I'm looking at it. I'm looking through the camera. Let's pretend this is my camera. I'm looking through it, and I just want to shoot this, right? Well, you can say OpenGL render image, and then boom, there you have it. Okay. I'll stop sharing.
So to make the movie from that, you click OpenGL render image, and then it just it will.
Let me share again. Let me share. Yeah, let me share again.
I had gone to that view to set things up, thinking I had it all set up, and then I
Let me share again. So OpenGL. I'm sorry. So exactly what I did was, so we did OpenGL rendered image just to render the image, right? Mm-hmm. But then when I'm ready to make the movie, I say OpenGL render animation.
Okay, yeah.
Instead of this animation over here.
Yeah, got it.
But the resolution of the image and the frame numbers are all controlled over here.
Got it. Yeah, I had set all that up. So
yeah, that's it.
I'm rendering like my cube with tiny little dots moving around on it. And I don't know if you can you interrupt this process? That's the other thing that.
Yeah, I think if you hit the escape key several times, it will quit. I think you have to point with your mouse pointer in the view that you see, and then you can hit escape a couple times. It'll eventually cancel. Is that working?
Yeah.
Okay. Good.
It's very sad. I don't know if I managed to get an actual file out of that.
Okay. So I'll show one more quick thing. OpenGL render animation. No camera. That's funny. So this is Randy saying he's getting an error that there's no camera. Well, I don't have a camera. I definitely.
Yeah, you have to go back to the. You have to undo the rendered image.
Oh, you mean, so if I say render image and I'm looking here.
You have to show hide render view in order to do that again. Otherwise, it
right,
doesn't
yeah.
understand.
Right, I see. Yeah, so Courtney's right. So if I'm looking at a rendered image and I try to render another one, it says no camera. So you have to, I usually hit escape to get out of that, to get back to this view. And then you can do it. Then you can say OpenGL render image. Okay. Very good. Thanks, Courtney. Okay, so I'm going to show one more quick thing here. Let me see if I can find it. I'm going to say open. And let's see, I'm going to go to.
Oh, we can't see your screen, by the way.
Okay, but let me, yeah, okay, let me pull it up first and then I'll share. Okay, this is under. Here we go. All right. I'm gonna go there. Okay. And there we go. This is cool. All right, you're gonna love this. Okay. Share my screen. Okay. What are we looking at? This is the movie that I showed you on Tuesday, but now we're looking at it from inside Blender using the interface in Blender. This is what I saw when I was setting up and making that movie. And this was rendered using the high quality rendering mode because I needed certain transparency effects and certain lighting effects that I couldn't get by doing just a plain OpenGL render. Okay, so here I am. I can zoom in and zoom out, and down here it says camera 4. This is the point of view of the scene from the point of view of camera 4, and in this view we can see our whole scene, and we see here's our little timeline with a little caret on it and our units on the bottom axis, and here's our timeline along the bottom. This has 5,400 frames. So at 30 frames a second, that's about 3 minutes of video. 60 times 30 is 1,800, times 3 is 5,400. And if I grab onto this timeline and pull on it, we can see the caret for the timeline starting to advance along our time axis. And now as we move in, we can see the particles diffusing and moving. Our camera is pulling in. We see the calcium ions. Things fade, become transparent. We see our flickering calcium, blah, blah, blah. So we see the whole thing from the point of view of camera 4. And I can go forward and back. I can go forward and back as fast as I want. It's the power of this interface is kind of astonishing. How high the performance is for doing this. Okay, I'm gonna close my door because we're hearing cats. We're hearing cats being scolded. Okay. So this is what we see from the point of view of camera 4. But if I middle click and drag on my scene, then all of a sudden I snap out of the point of view from camera 4. In fact, this is camera 4. If I click on it, it says this is camera 4. And now I'm looking at my whole scene from the side. Now I'm the director. I'm not the cameraman, right? But if I hit the 0 key on the numpad, the 0 key is the hotkey. If I go down here to view, the different views are view camera, numpad 0. So now I can, if I hit numpad 0, this snaps me back to the point of view of camera 4. Okay. And if I hit 0 again, then it puts me back to the view I had a moment ago. And now from this point of view, if I move the timeline, we can see the camera moving and changing angle, and then it kind of stops right there for the rest of the movie. And we can, and from this point of view, we can see all the other things that are going on in my scene. So here, the dendrite is opaque, but at a certain point, the dendrite becomes transparent, right? And we can see all that happening. And then we can see this flash of yellow on the dendrite. That's when the dendrite is depolarizing because of the back propagating action potential. Actually coupled the brightness of the color to the membrane potential of the dendrite. And I did the same thing with the axon as well. I can see the axon becoming a brighter shade of green there and then darker green. It's pretty cool. And I can look from any point of view. I can zoom in here. I can zoom all the way in here like this and move around. And in fact, if I go through my list of objects over here in this model, I can find the object that represents the synaptic vesicles. And I can use the dot key on the keyboard on the numpad. The dot key on the numpad makes the vesicles be the center of the field of view. And now I can kind of pivot around this synapse and move the timeline and watch the release of neurotransmitter. There was the release of neurotransmitter right there. Oop, I'm sorry. I glitched right there. And I can use the arrow keys to step through time. Let's see, where's that release? There it is. I can rewind and look at the neurotransmitter being released, going back and forth, and look at this, say, from the side, like this. And I can see the neurotransmitter was released from a vesicle kind of over here on the side of the synapse, and it diffuses around, and I can look at it from the back side, and I can see the neurotransmitter kind of diffusing through the synaptic cleft, which extends up through here. It's pretty nice. But then I can go back to here's what camera 4 sees. Okay, so that's probably plenty for today. It's 4 o'clock, it's just after 4 o'clock. And I did what I promised to show you how to make a simple movie, and then I gave you a little teaser on more advanced things you can do. Okay.
Thank you very much, Tom. Yeah, it was amazing.
Thank you. You're welcome. You're welcome, Mohammed.
Thanks, Tom. That was a good use of time.
Good. Thank you. And I'm glad we caught it on the recording. I'm going to stop my sharing at this point and take any final questions from people, and we'll continue tomorrow.
I guess quick question.
Sure. Go ahead, Mohammed.
So Tom, I just wondering if so after these synapses fire, if we have a number of these presynaptic boutons firing and releasing the neurotransmitter, and then the postsynaptic, the synapse, the spine head volumes, the surface area, they absorb the more neurotransmitter, and then we can have action potentials. And if we have LTP occurring in that synapse, then we have enlargement of the synaptic morphology and the size. So is that something we can show with CellBlender, that this video shows that, I mean, by some logarithmic scale in the time, you show that the morphology also becomes bigger, and we show LTP with a movie?
It could, yes, it could be done. Of course, we don't really know all the biochemistry of how that happens for real. We have some ideas about how that happens. But if we had those details, we could include it in the model. Certainly, MCell can, you haven't seen, there's an advanced model that, I think we'll have time tomorrow. One of the examples is on dynamic geometry. It's one of the examples. Shows that MCell can do dynamic geometry. And so if we knew how the biochemistry led to the change in size and all that, we have, there's some experimental, results or, physiological ideas on how that happens, but it's not really all totally worked out. We could certainly include that in the model, and MCell would be able to, and of course Blender would be able to show that happening. Of course, if you don't know how it really happens, you could make up a story and a cartoon and make, of course, in Blender, it's just your imagination. You can do anything you want from your imagination in this tool as well. But that's not why we're here. We're here to try to make the model be true to life and realistic, right?
Exactly. So dynamic geometry is the answer. So it was I haven't heard of it. So thank you very much. And then the second question is that, so these are just showing one synapse. Do you see this capability, or, I mean, maybe I'm not very knowledgeable in terms of what are the 10 years or fundamental goals you have, the goals you put for next 5 years, 10 years to achieve with these movies, with these simulations. But just a naive questions that came to my mind is that, can we have 10,000 synapses, 100,000 synapses in this CellBlender in a much more reconstructed cube, or simulated reconstructed cube, not a real reconstructed, but a simulation of 100,000 synapses? They make LTP, they make they make the changes, and we see the outcome. I mean, as a tools for simulating the brain with 100,000 synapses rather than 1 or 2 or 10.
I think it's possible. It's just, who was it? Archimedes said, give me a lever long enough and a place to stand and I can move the world, right? I think that was Archimedes. So same is true of computing. So I don't want to say no to what you said. I want to say yes to what you said, right?
Yeah.
And
it's hard.
Yeah. But the journey of 1,000 miles begins with a single step, right?
Exactly. So yeah. These fundamentals, these pieces. So I end my discussion with this, that I believe all mathematics is summation and subtraction. So this is also true about what you said. So those big models are starting from these small synapses or these units of the big picture. Yeah, thank you.
And there's the basic way you go about it is there's an optimization strategy, or just a general strategy for accomplishing big things. And it's called divide and conquer.
Yeah.
Right. So you make a team, you divvy up the work among the team members, divide the work among them, right? And then everyone sets about doing the work. And I think Don Spencer, from his extensive background of being, a big project manager at Northrop Grumman, he might be the best person in the group to talk about how that is done. But this is how the seemingly impossible gets done, right?
Yeah.
We can look throughout the world at incredible accomplishments being made today, and many examples from the past, ancient wonders of the world like the pyramids, etc., where we look at some of these things and we say, oh, it must have been aliens who helped, right? One of the examples that I really like to look at is the Inca ruins of Sacsayhuaman in Cusco. I don't know if you've ever been there or know about it. There are stones that are fit together there, that are fit together so perfectly, and their shapes are so complex, they fit together like pieces of a jigsaw puzzle. So they're not just square or cuboid blocks like the pyramids, it's even much harder than even the pyramids.
By nature.
How it was assembled. These blocks fit together so tightly that they're practically watertight. Certainly you can't fit a sheet of paper. You can't slip a piece of paper between these stones. But the stones weigh 100 tons. So these aren't small stones. These are huge stones that they not only had to move into place, but fashion to fit together. It's unimaginable how, I don't know how it was done. But it wasn't aliens who helped, right? It was a divide and conquer strategy that they used to do it.
I see. Thank you
Anyway,
very much.
we're going off on some tangents here a little bit.
Yeah. Thank you.
Sure.
Yeah. Maybe to clarify one thing regarding tomorrow. So what is the schedule? The current is bioenergy and then cell organizer and then MCell.
Well, that was the original plan, but I think people said, let's start with the MCell. Jim Fader said it was fine to start with MCell at 7:30. So that people in Europe will be on earlier in the day and be able to see the demonstration of NeuroPill tools and how we import models from 3D EM data sets.
Okay, and regarding NeuroPill tools, I can post, maybe I can enable my camera. I can post a guide how to set up a virtual box with Ubuntu. But
Okay. Oh, that would be, yeah. And if you could, and if that Ubuntu image already has the latest CellBlender bundle in it with NeuroPill tools.
Okay. Just
It needs to.
It will be huge. It is like, I don't know, 20 gigabytes. I'm not sure if the people won't be able to download it in time.
Yeah, it's probably better to not worry about it.
Okay.
Adam.
Mm-hmm.
And so Windows, yeah, we'll I think that's, we're trying to push the envelope a little bit too much.
Okay, and hopefully there won't be any random errors, like that tested it just on a single geometry and it worked fine, but
right.
Okay.
So Kristen earlier today shared with me the data set that she would like to use for that demo tomorrow. So tonight I will try it to make sure it really works. So that's kind of vetted before we get together tomorrow.
Okay.
To make sure it's good to go.
Yeah, maybe send it to me as well. I will test it on Linux.
Okay, sure. It's yeah, and maybe Adam, we could Zoom together a little bit. So what's your in case you need some guidance from me to help put that together?
It's okay. Just if you can send me, okay, maybe we can discuss this over email.
Yeah.
Just the .cr files. That's okay for me.
Yeah, exactly. Those are the files. Yeah, I have a zip file of that project that Kristen sent to me. I will put it on my space at Salk, and you can grab it from there. Okay. And
maybe to, I know that probably other people don't need to hear this. So the demonstration, you will start with the SCR files, or
yes,
like with no iMod.
Yeah, not iMod.
Okay, great.
Yeah. It's just going to be what we know should work.
Uh-huh.
Yeah.
Okay.
Will you be you'll be using the Zoom thing that's on for tomorrow morning, right? That was actually
Yes,
Jim.
that same link. It'll be that. Well, what I'll do is I think I have access to this document, and I will the links are correct.
Yeah, I mean, it's there. You're not going to use the one in the afternoon in the morning. You're gonna
Right,
use
right.
on
What
the-
I'm going to do is I'm going to update the agenda though, so that the morning says CellBlender and the afternoon says BioNetGen.
Okay, you might want to say it starts at 7:30 because that's a change.
It does, yeah. It does start at 7:30. Yeah. So, yes. So that 7:30 time is correct. Let me paste it in there. So I've changed it. So now it says CellBlender in the morning, Cell Organizer mid-morning, and then BioNetGen in the afternoon after the lunch break.
I think Jim said he will be still available in the morning.
Yeah, yeah, and Jim will be there in the morning. Yes. Okay, so I've updated the agenda to be the new topics that we talked about. And I will do my best to try to get to the other things that I said we should get to in the MCell advanced topics. Okay. So it looked like Junhao asked about convective flow in CellBlender. So not right now, but in the new version of MCell 4 that Adam is helping to develop, we should be able to have other models of diffusion besides isotropic random walk. So you should potentially be able to have convective flow with that. So that's still in development. Okay. So it was really great day that we had together. Thanks for being here. And I don't know about you, but my brain is full. And we'll see you tomorrow.
Thanks, Tom. See you tomorrow.
Okay, thank you all.